Hello, Maurice here. In this video we should look at a few examples of some integrals. So we can start with a very simple example similar to one that we did before. Say we have the x square curve from 0 to 1 and we want to find this area here. So we have to remember two important formulas to work with. One of them is this theorem of calculus formula. So we have that the area equals the integral from a to b of your function. Next step we need to do is to find our antiderivative or primitive function. So that is capital F of x. We don't need to care about the constant since that will cancel away anyhow. From a to b, and then we plug in the value b. So f of b, and then minus plugging in the value of a. So that is the key formula we will work with. And secondly, we will work with this one, that the integral or the antiderivative of x to the power of n dx equals to x to the power of n plus 1 over n plus 1 plus c. So we have these two formulas to work with. Okay, so let's look at our particular problem here. So we want to find the area from 0 to 1, so that will be integral from 0 to 1 of our function, that is x squared dx. So in other words, the area from 0 to 1 of x squared, and the integral will be taken with respect to x. And that will be our antiderivative or our primitive function of x squared, which now will be x cubed divided by 3. We just follow this rule here, right? When x is 2, from 0 to 1. First we plug in or substitute in the 1, so that will be 1 to the power of 3 over 3 minus, and then 0 to the power of 3 over 3. The first part will be 1/3 and the second part will be 0, so the area will be 1/3. We can check this with the calculator too. So I go into the ordinary run mode on the Casio, that will be different on different calculators. Options, calculus, integrals of, and our function was x squared, right? So x squared from 0 to 1. And that will give us 1/3. That works fine. Let us look at another example. In this case, I will take the square root of x function instead, yet again from 0 to 1. So we will find this area over here. So our expression for the area will be the integral from 0 to 1 again, but now of square root of x dx, and that can be written as the integral from 0 to 1 of x to the power of 1/2 dx. And now we should follow this rule again here, but with n being 1/2. So we can see that that will become x to the power of 1/2 plus 1 divided by 1/2 plus 1 from 0 to 1, or x to the power of 1/2 plus 1, that is 3/2, right? Divided by 3/2. And yet again from 0 to 1. Here I will multiply both the numerator and denominator. So I will multiply this by 2, and the same thing here. That will cancel the 2 against the 2. So that will give us 2/3 of x to the power of 3/2 from 0 to 1. That will give us 2/3 times 1 to the power of 3/2 minus 2/3 0 to the power of 3/2. This part here will become 2/3, right? And this part here will become 0. So that will give us the answer 2/3. And yet again, we can check this with the calculator. The integral of square root, so shift square root of x from 0 to 1, end bracket, x, and there we can see that we get 2/3. This actually makes very much sense if you think about what we did, because the first integral we did was taking the area underneath the x squared curve, this part here, we found that that was 1/3, and then we took the integral of the square root of x, we found from 0 to 1, both of these, and we found that that was 2/3. But if you think about this a little bit carefully, we can see that this area here actually will be the same as this area over here, because the squared curve and x squared curve are inverse to each other. That's pretty cool. And of course, if we add these two areas, we get the area 1, because if we look at the square curve, 1 square is 1. So we have the square curve like this, and the square root will be the inverse of this. So of course that will form a rectangle with the area 1 times 1 is 1. 1/3 plus the 2/3 equals to 1, which is pretty cool. But anyhow, we can see that we can do integrals also with functions like this, square roots and the like. We continue with a few examples in the next video. Ciao!